Alright, the chopper just landed, but I'm here.
This is the production manager, Jeffrey Welt. So, what's going on here, Mr. Welt?
Today we're conducting an experiment, very expensive experiment, on behalf of these two over here, who are...
They making out?
I'm not quite sure what they're doing, but I know it has something to do with science. But don't look at that, because we don't want any liability over there in case they get hurt.
True.
Is there any questions you think that I should be answering?
How much money did this cost?
It's about like $4.2 billion.
Wow, that's. I mean,
it's a small budget thing, but we're gonna see if we can accomplish as much as possible in relation to this rocket experiment.
Where'd you find all the scientists for this? Well, I mean, the one scientist, Ian Feinberg. Where'd you find him?
Ian
He's a
Feinberg?
sexy man. Yeah.
I looked at some pinup pictures, and I don't know, that one, he just caught my eye.
Oh, hi. Now I've been doing this for a while, these experiments, and I gotta say I've become quite the expert. Now, when we look at these studies on the impact of acceleration due to the ecological impact of crayfish, I must say that the effects have not been highly tested yet, which is why our experimental procedures today could influence science as we know it. Now, here in the wheat field, we have our certain standard procedures, and with our help today, we will unravel the mystery of these effects.
So what exactly is your expertise in the department of this forceful object hitting that there metal thing over there? Sammy, I like to call it, to be more scientific.
Alright, now, Sammy, here, my boy, when it impacts the metal pole, or tube as we would like to say, whichever object it has a greater density and mass will survive the experiment. Unfortunately to say, I don't fare, my previous predictions have not fared well for the crayfish, but what we can say with certainty is that this rock will remain intact and quite possibly dent the cylindrical object.
So, now some people might be highly skeptical of what exactly this guy is talking about. Can you please give me some credentials, sir?
Yes, I'm actually a biology major at the University of Buffalo, and I also happen to be a professional crayfish cartographer of the area, so I know the layouts quite well. Also, I have background in paleontology and geology, which makes me fairly certain that this igneous form of rock will do fairly well against the corrosive metals of the pole.
Wait, over here.
Oh. Well, hello there. I didn't see you. So,
what are you doing here now? This is for the record.
oh, I am the government supervisor to make sure this all goes according to plan.
According to plan, huh?
Yes. You see, if one small slip-up occurs, we could all die.
How is that possible? Because I don't want that to happen.
You see, we believe that there's a fault line right down here. A very thick one, full of bad things. If we tap that, we could all just we could all explode. All right?
Okay. A rock, huh?
Yes, a rock. You see, it stands for a rock.
Okay. So can you tell me about your credentials? Why exactly are you here today? Like, why'd they send you?
Oh, they sent me because I'm the best of the best.
You're the best of the best, huh?
I am the best of the best.
Where did you learn to do this?
I learned lots of books. I read them.
You read them? Who hired you?
Who else? Who do you think? George Bush.
George Bush hired you? What?
Yes.
Why?
A man amongst men.
Now, what does the government have to say about the importance of these experiments? Because we really like to continue them. I don't think this experiment's going to give us all the answers that we need.
Of course not. I mean, there are lots of things we don't know about these rocks. I mean, what's inside them? What makes them tick? Why do they kill? Hundreds of people are killed each year by rocks. In order to defend our people from these murderous rocks, we have to get inside the rock. But the problem is, rocks are hard. So we believe with this experiment, we will find the breaking power of this rock, so we can get inside his head and stop.
Welcome back. It's been about a month since our rock experiment, and we have devised a new experiment. This one, instead of testing gravity, we're going to be testing force. Hand down this rock here. See this massive rock? It weighs a lot.
This is an onion.
Or this onion. We're gonna toss it onto that pipe and see how much we can dent it.
Yeah.
Highly experimental. The funding for this was astronomical.
Wait, what was it?
What was what?
The funding?
Astronomical. Like a lot. Astronomical. A ton of money. So, here we go.
No.
Oh, we're about to get this experiment underway.
We're gonna toss this killer, this potential killer.
This potential killer right here, we injected it with some antibiotics to keep it from fighting us.
All right.
Alright, you got it? It's a good thing we did stretching with Ian first.
Oh, good thing. Okay. Ready? 1, 2, 3.
Ready?
We're gonna do 3. 1, 2, 3.
Yeah, let's do
1, 2, 3. Woo! Woo! All right. So, I'm Professor Feinberg, the expert on force and rocks. As you can see, the rock landed here. These are just marks of the actual rock itself. The pipe sustained no real damage at all. In fact, I'm not even sure how this happened to this pipe here. So, we pretty much just wasted almost $5 billion on this.
Yeah, because we had to pay these people too. How much money do you think it'll take to finish conducting the series of experiments that we need here?
At least 3 times as much.
Keep our pensions in mind and how much we're going to need to retire.
Right. Retire young, by the way.
Young, very young, because this is this is going to revolutionize the scientific world.
I think that maybe another $6 billion should be enough to cover the experiments that we're going to need, actually. My earlier estimate, I just said 3 times, probably about just 6 billion. That should be enough to actually dent this pipe and see exactly how big of a rock we need. We may need to hire another research assistant to help us. But other than that,
some workers.
yes.
I know some workers.
Yeah. Preferably, you know, not preferably, whatever, you know, whites, doesn't matter. As long as they can lift the rock with equal, you know, good strength, no matter if they're
I mean, we are strong enough to lift that rock, but who knows what we'll be testing in the future.
Oh, yes. Interesting things we find down here in these creeks. not to take away from our previous experiment, but well, I should stop playing with that. The crayfish of these ponds, they seem to sustain some ecological displacement after the experiment of the rock. Habitat surroundings, so that the crayfish would have to find a new niche within their succession of habitats. However, I do have, after results of the cartographer who has mapped out the area over here, we have found that they have moved, they've congregated to a farther slot down the stream. After discussing my results with Dr. Lasker and numerous members of the scientific community, we have discovered that indeed they have moved. So that's my discovery for you.
The mystery.
The mystery.
Yes, the mystery.
The
Until we
mystery.
reach our climax, which
Until we
hopefully
reach
should arrive smoothly.
Hopefully smoothly, yeah.
This isn't a parody of science.
Ghost away, scare away that ghost today.